I'm going to talk about graphing in a different way than what you've probably been exposed to. So hopefully you kind of remember some of what you have been exposed to. I'll talk about that later in the next class as well. But I do want to talk about the approach of graphing or sketching graphs by transformations. Okay, so when you're graphing by transformations, everything is based on a parent function. And a parent function is just the most basic function. In a family of functions. Okay, so the parent function that we're going to talk about to start with is just y equals x, or in this case, f of x is equal to x. It's just the most basic one. There's nothing that is there's no transformations being applied to this graph. All you have is your basic graph. Okay, so for a y equals x graph, the parent function or the graph itself that everything is based on looks just like this. Okay, so when you're doing graphing by transformations, you always base it on whatever your parent function looks like. Okay, so just to give you a heads up on a couple others that you are going to be seeing, this is the parent function, y equals absolute value of x. This would be the parent function, y equals x squared. Okay, so again, what's happening here is there's nothing being performed to this. There's no adjustments, no shifting, no stretching, no reflecting. It's just the most basic function you can have in a linear graph or an absolute value graph or a quadratic graph. Okay, now the transformations that apply to this are based on this function notation. So again, it does require that you be familiar with that a little bit. Okay, so the first transformation we're going to look at is adding or subtracting something to the outside of our function. Okay, when you add or subtract a value outside of a function, you get a vertical shift. Plus means you go up a units, minus means you go down a units. Okay, so if we're going to take our parent function here, again, we're taking this basic graph, and if we apply a shift to it, so if we wanted to sketch the graph of y equals x plus 3, what we're going to do is we take our parent function, and this vertical shift occurs outside the function, so we're going to move it up 3 units. So this point right here gets moved 1, 2, 3 units, and then the entire graph stays exactly as it was. Okay, so this would be our function, or the graph of that particular function. And now, is this consistent with what we would expect if we're looking at it as by slope-intercept? We have a y-intercept of 3, so 1, 2, 3. Here's our y-intercept. Our slope of 1, so we go down 1 over 1, down 1 over 1. And so it's consistent with what you would expect if you're looking at it by slope-intercept. Okay, so that's vertical shifting. And we also have horizontal shifting. And that occurs if the transformation is happening inside the function. If you're adding or subtracting something inside of your function, then you get a horizontal shift. Okay, and the shift is okay, so the shift that occurs is whatever value of x that gives you 0. Okay, so let's come down to this function again. Or actually, I'm going to use this absolute value here for this example. Okay, so if I took something like this, because it's easier to see that this is a shift that occurs inside the function. Okay, so does everybody see how this plus 3 now isn't outside of our function, it's on the inside of our function? Right? It's embedded within our absolute value graph. This is our parent graph here, parent function. Okay, so if we look at our parent function as this V shape with 45-degree angles, okay, what value of x, so we have this transformation occurring. It's inside our function, so we know it's going to be a horizontal shift. And what value of x would give you a 0 inside here? 3 or negative 3? Negative 3. So negative 3 is a shift in which direction, to the left or to the right? So negative 3 is going to be a shift to the left. So this point gets shifted 1, 2, 3 points to the left. And then again, it has that same 45-degree angle, V. So this would be our graph after this horizontal shift. And now let's take a look at the linear graph, because there's the linear graph, you can't, if all you have is this plus 3. And so if I take my y equals x plus 3 again, that plus 3 can be thought of being inside of your function, and the way that it's written right here. So if this was thought of as being inside our function, then which direction would we shift? What value of x would give us a 0 here? It'd be negative 3, right? 1, 2, 3. So we'd get our shift over this way, and then it's the same graph. Okay, now, does it matter whether we think of this as a vertical shift or a horizontal shift? Or is that the same graph? Is this the same graph as this? Yeah. So when you're talking about these shifting, the horizontal or vertical shift, for a linear graph it doesn't matter in the form that it's in. As we start to add other elements, it does matter a little bit more. But if it's just the x by itself, this plus 3 can be thought of, or it's consistent with both the horizontal and vertical shift. My suggestion to you, use the vertical shift. It's easier to visualize that. And the horizontal shift rules won't apply if you start to add some other things to it.